In this session, we're going to give you the comprehensive power repair guide and talk about how to accurately judge when it comes to abnormal power electrical problems. For previous slide, we talked about the procedure to ensure IC is normal and enable LDO. While in this slide, we're going to enable pin 2 and pin 4, which is N-trip 1 and N-trip 2 to turn on the power so that the voltage of 3 volts and 5 volts is able to reach 2. In A group, it can be fed with 3 volts and 5 volts only when the voltage is pulled down to ground. In other words, floating cannot be considered as a state to make 3 volts and 5 volts enabled. As you can see, the signal of pin 2 and pin 4 is given from EC. And once EC works, the signal will be sent out to trigger power sequence and also be pulled down to ground state. Therefore, it will be normal to measure a non-zero voltage on N-trip 1. So technically, step 9 is more like an action to detect if EC is working and give out the signal. When everything is ready without anything wrong, then the conversion to output 5 volts would get started. Same action for the conversion to output 3 volts. In conclusion, at the beginning of electrical circuit, by the time the input is ready, enable signal is ready, and EC is about to work, but the output voltage is found failed to be given out. The reason caused that failure is probably because mode is out of order, and thus to make output convert unsuccessfully. So please check the mode to ensure if there is any problem on it. Debugging logic for B group is basically same as A group, but still the minor difference exists. For example, the way to ensure that EC works is different between A and B group. In A group, the signal from enable pin will be pulled down to ground state, while the way that enable pin would do in B group is to receive the signal from EC directly. From step 1 to step 7, they are all same as A group. Check if they are ready and all in the position to generate the power. To begin with, check with Vin and LDO. Next, check the impedance of enable 1 and enable 2. Once the impedance checking procedure is done, go to step 6. To measure if the value of AC battery system is around 19 to 20 volts, and the value of IC Vin is also 19 to 20 volts as well. Finally, the voltage of LDO3 and LDO5 should be 3.3 volts and 5 volts respectively. If not, look into EC and low switch IC to see which one goes wrong. Compared to A group, here comes the difference we just mentioned earlier. In B group, EC will send out the signal directly to let enable 1 and enable 2 know that they should be ready to work. And here is enable 1 and enable 2. That is to say, without any action of pulling down to ground state, IC in high level goes straight to indicate that it should be enabled. On the contrary, IC in low level means it will be disabled. Since the signal of 5 volts and 3 volts are both coming from EC, So step 9 and step 10 are the main steps to check if their voltages are acting normal. And as you can see here, enable 1 is over here, and enable 2 is here. In the section of the switch IC, it contains the voltage of Vin, VCC, and enable pin. And in this diagram, VCC, which is called VBIOS, is the voltage to make IC work, while enable pin, as you can see here, shows on 1 and on 2, can decide the conducting state between input and output. The switch IC is like a switch to make current pass by, and it will be physical to turn on or turn off this switch. And this switch is enabled with the premise that EC has 3 VA comes out first, and then follow it up with 3 VA EC, which in other words, EC converts 3 VA into 3 VA EC. With the overview of the switch IC, let's take a look at its repair guideline. First of all, ensure that 3 VA EC works well for the output 1 and the output 2. Next, Vin 1 and Vin 2 are also required to measure the value of impedance. Normally, if nothing wrong with system IC, then there should be 3.3 volts that is given by LDO. Furthermore, since it connects to VBIOS pin, which is considered VCC of IC, that means VBIOS must be active first to trigger the enable pin. So once something abnormal happens, during step 1 to step 4, basically it can tell that it must be IC giving rise to some sort of problems due to the decline of voltage. Therefore, output must have current after the enable pin sends out the voltage of 3.3 volts. If not, better check with the backside or front side of the device to see which part is going wrong. And since on 1 and on 2 are both given by EC, so it would be abnormal if there is no output. Please go to EC or PCH component to find out short circuit. From this slide, we are going to give you single IC repair tutorial in condition of without LDO and with LDO. So let's go to the aspect of without VTT first. Here is the overview of the current flow in single IC without VTT. First and foremost, see if VDD or VCC come into play in IC. Besides, check if enable pin from pin 7 to pin 9 got the electric from EC. Last but not least, it will start doing conversion once everything is ready. From step 1 to step 3, measure the impedance of VDD and enable pin from pin 7 to pin 9 to confirm if their value are all over than 100 ohm. Followed by voltage measurement. Theoretically, there must be 5 busas to enable IC. Otherwise, please refer to System IC Repair Guideline. This example shows the output of 1.05 busas will be converted into South bridge, and since one of the enable pin, which is S3 over here, will connect to ground state, so there's no need for South bridge to use LDO.